Hello, grade 10 learners. How are you? I hope you are all doing well. And despite this pandemic, education must or should continue. Again, this is teacher Jethro Odoy, your guide in exploring the exciting world of science. And this day, we will be talking about a particular topic under physics, under your quarter two, which is about electric motor and generator. Let us begin. At the end of the lesson or at the end of the session, you will be able to explain the operation of simple electric motor and generator. You can also describe electromagnetic induction. At the same time, you can explain how electric motor and generator work. Now, I want you to think of the different appliances inside your house. I want you to list down or identify the different appliances inside your house. Have a tour, or you can roam around and check whether you have these example on your screen, the different appliances you might have. Example, a television, a washing machine, a kitchen appliances, electric fan, whatever, any appliances you can find inside your house. And now, here's here's the catch. I want you to identify among those appliances you have inside your house. I want you to identify only those appliances that use electric motor to operate or to function. What do you think are those appliances which use electric motor to function? Do you have a hint? All right. Now, later in this session, we will be talking about a specific machine that you can find inside a specific appliances, such as your electric fan. You might be wondering how electric fan works, right? Especially now, summer is approaching and every one of us, even we have an air condition in our house, we even wanted to have excuse me, we even wanted to have an additional cooling system like an electric fan because it's very humid and it's very hot, especially the summer is approaching. The weather is hot and humid. So, for example, your electric fan, which we have, almost of us has this appliance, there is that special machine, you call that electric motor, that is responsible for it to function fully or well. Okay, that's the case of electric fan. And even your blender, or when you wanted to have a refreshment in the afternoon, have some fruit shake, you need to have an appliance, so-called blender, right? So when you want a fruit shake, you will just mix everything and shake, and then inside that appliance, the shaker, no, is that a shaker? That's a blender, okay? There is that special machine inside that. When you uncover, when you dismantle that appliance, you can see a special machine. We call that electric motor for that appliance to function fully. Okay, now we will try to explain that later. Okay, what are the mechanisms or what are the concepts behind electric motors? All right, let's proceed. Now, I'll be telling to you a very nice story. I call this story a story of serendipity. But before that, I want you to check the meaning of serendipity. In my own words, in my own definition, I define that as a lucky accident. And why? You'll find that later. Now, these two personalities, a big name or a very famous, well-known personalities in the field of science, especially in physics, electricity, started their career in early 1800s or 1820s to be exact. So it was during the class, because Ørsted was a professor before, aside from being a scientist, was a professor, and during his class, okay, there were a huge crowd of students, and then one of the curious students approached him, and Ørsted, during that time, during his lecture, he had really no idea. He had no idea that there exists a relationship between magnets and electricity. And during that session, or during the discussion or lecture of Ørsted, he was trying to demonstrate how electricity works, like in the middle picture, okay, this was the model or this was the demonstration presented by Ørsted during his class. However, because of curiosity, one student approached him, and then that student carried a magnetic compass. You know what is a magnetic compass? That is a device used for you to navigate, especially when you are a sailor, you are working in a ship, okay? That will tell you the direction, where is north, where is south, where is west or east, okay? Basically, it tells you the direction, and it is affected by the largest magnet or the Earth, the magnetic field of the Earth. Now, this one student, accidentally or placed the magnetic field beneath the electric wire. And then Ørsted was surprised. Why? Because the needle in that compass deflected. Okay? Deflected. And he wondered, why? Okay, why? Bakit kaya? Anong meron? Bakit nag-iiba yung direction ng needle? Okay, again, Ørsted tried again. Can you remove the ano? Sabi ni Ørsted, i-remove mo nga yung ano, yung magnetic compass. Kung mag-move ba siya the same way pag ilapit natin siya sa wire. So kinuha nila. Nag-move siya according sa direction ng magnetic field ng Earth. At sabi ni Ørsted, sige, ibalik mo. Okay? And then the student again placed that beneath the electric wire. And then it deflected again, meaning nag-move siya. Then sabi ni Ørsted, there must be something. Okay? Meron talagang force na nag-i-exert yung electric current. Sabi niya, kung merong force, kung nag-move yung needle or magnetic needle ng compass, there must be a force that is being exerted or that is being produced as the circuit is plugged in or as the circuit or along the circuit. Tapos sabi ni Ørsted, alright, meron talagang epekto kapag meron talagang force na bubuo kapag ang circuit ay naka-plug in or mayroong power source. So therefore, there is that field, okay, na nakakaapekto sa magnetic needle ng compass. So therefore, because of that serendipity or lucky accident, na-establish ni Ørsted na ang electric current ay nagbubuo or makaproduce siya ng electric field, which causes or which affects the magnet. So therefore, there exists, okay, na-conclude ni Ørsted na there exists a relationship between electricity and magnetism. Now, ano naman ang role ni Faraday? Sabi ni Faraday, kung merong relationship ang magnetism and electricity, I will try an experiment, sabi niya. Okay? Instead of placing magnetic compass, sabi niya, why not? I will create a circuit pero hindi ko i-connect siya sa power source. Meaning, gagawa sila ng circuit, pero hindi siya nakakonect sa power source, sa battery. Ang ginawa ni Faraday, kumuha siya ng galvanometer. Alam niyo ang galvanometer? Ang galvanometer, it is a device used to measure if there is an electric current flowing along the circuit. Okay. Ginamit niya yung galvanometer. Kumuha siya ng wire, tapos mayroong galvanometer. Okay. Ang ginawa niya, kumuha siya ng bar magnet. Tapos yung wire, ginawa niya yung coil. Okay? Yung coil. Okay, I'll be showing you the coil later. Sabi niya, what if yung coil, ilagay ko doon yung magnet. So, I will try to move closer or ilagay ko doon, papasok yung bar magnet sa loob ng coil. Tingnan ko kung mag-move ba yung galvanometer. To his surprise, ang nangyari, yes, nag-move yung galvanometer. Okay? by using or by moving only the bar magnets. So therefore, na-concretize yung idea ni Ørsted. Sabi ni Faraday, talaga nga, okay, makabuo ka ng electricity out of magnets by moving the magnets. Okay? Kung i-move mo yung magnets malapit sa coil ng wire, makaproduce siya ng electricity. That is why we have generator right now, which is very useful. Okay? Para magkaroon tayo ng power source. Like we have in Davao City, nagkakaroon tayo ng electricity because of the invention or discovery of these two famous scientists in early 1800s. So, that is why serendipity, kasi hindi nila inaasahan yon na pangyayari. Nangyayari lang talaga ng kusa. So, that was a lucky incident or accident for both of them. And because of that, serendipity nagiging famous at well-known sila. And we are living a very comfortable life because of them. Okay? Without electricity, imagine life without electricity, di ba? I cannot imagine life without electricity. So that was the story, a very short story of Ørsted and Faraday. Now, what is electromagnetic induction? The idea of electromagnetic induction was created after the invention or discovery of Christian Ørsted and Michael Faraday. Ang electromagnetic induction, it is a concept where it will tell you that by moving the magnet, for example, in the diagram shown, by moving the magnet, okay, which has magnetic field, it can cause flow of electrons, meaning or flow of current. So makakabuo kayo or magpo-flow yung current. Okay, merong current flow kapag may movement yung bar magnet. Kasi because of the force exerted by the bar magnet, we call that magnetic field. Okay, so by moving the magnets, the bar magnet, for example, inside a coil, it can produces or it can generate what? Electricity. That is the idea of electromagnetic induction. And I want you to remember that concept. Now, these three pictures will show you the different direction of magnetic and electric field. In the first picture, it shows you the magnetic field of a bar magnet. Because we all know magnets have north and south pole. In this case, we have north and south. So that the direction of magnetic field looks like circular. Parang circular siya. It goes out from the north and then goes back to the south pole. Ganyan yung direction ng field, magnetic field ng bar magnet, ordinary magnet. How about yung wire? Kapag nakasaksak siya ng kuryente. Okay, for example, this wire in the middle picture, this is a wire, a copper wire, for example. It will generate magnetic field, okay, in circular, okay. I'll tell you later yung formation or yung direction ng magnetic field in detail later, in the next slide. This one, when you try to make a coil out of a copper wire, parang i-coil mo siya, you know what? Maiiba yung field direction niya. Magiging parang bar magnet siya, like the first picture. Okay, yung direction ng magnetic field niya ay the same as the first picture. So therefore, in other words, kapag meron kang wire, tapos mag-create ka ng coil, ang epekto niyan is that ang direction ng magnetic field will be the same as magnet. Therefore, magiging magnet yung coil wire niyo. At pag meron kang ilagay closer na objects which are metallic, it will attract because this wire, when you coil that one, it becomes a bar magnet. Okay? Becomes so-called parang bar magnet na rin siya kasi yung magnetic field niya ay the same as sa bar magnet. Kumpara dun sa wire na straight lang, like in the middle picture. All right, let's proceed. Now, this is a simple circuit. You have this power source, the battery, you have this bulb, and then you have the positive and the negative. So the direction, the conventional direction of current is from positive back to negative, positive back to negative. So every time there is a power source or every time there is a flow of current, there is a flow of electrons, what it can produce, ano yung maproproduce? It can produce electric field or magnetic field. Now, how will you identify the direction of that field? Remember this curl right hand rule. Okay, remember that when you have your right hand, just do this. Okay, imagine that the direction of a wire, this one going upwards sa thumb mo, if that is the direction of the wire, ang direction po ng magnetic field ay circular. Okay? Yung naka-curl sa mga fingers nyo. That's the direction of the magnetic field in the case of a wire or conductor. This one, this is what I am telling you, the solenoid. When you coil the wire, okay, yung epekto niya is magiging magnet siya. So therefore, ang magnetic field niya ay the same sa magnetic field ng bar magnet. No? Amazing siya. Kapag i-coil mo yung mga wire, magiging magnet siya. Kasi yung direction ng electric field or magnetic field niya ay magiging parehas sa direction ng bar magnet. Okay? So, magiging magnet siya yung coil. Kapag ganito siya, i-coil nyo. Now, this time, I'll be showing to you a special video. This is by Jade Owen. And I want you to get your notebook and pen and write the important concepts because you will be learning a lot out of this video. This is the video is all about how electric motor works. It will tell you some basic concepts of magnetism and electricity. All right, enjoy and have fun.
If you look around your house, you will see many devices that have electric motors, such as kids' toys, table fans, toothbrushes, hair dryers, and this electric cutting knife. But how does the electric motor work? You turn it on and somehow it starts rotating. Why is that? In this video, we'll cover the basics of electricity and magnets, and then put it all together to understand how the motor works. This video is sponsored by Brilliant. Let's start with something called a circuit. You have a battery, some wires, and a device that uses electricity such as a light bulb. Electricity flows through the circuit. But as soon as there is a break in the wire, the electricity stops flowing and the light bulb goes off. The path must be complete for the circuit to work. This is best done through the use of a switch. Electricity is flowing down the wire. This is called conventional flow. If we take the battery out and flip it, then the current will flow the other way. The light bulb will still work in either case, but there are some devices that will work differently depending on which way the current flows. Okay, so that's the basics of a circuit. Now let's come over here. This is a magnet. It has a north pole and a south pole, and it likes to attract other metal objects like these paper clips. If you bring another magnet towards it, opposite poles attract, and the same poles repel. Magnets don't have to be in this shape. For example, some magnets might be more flat like this. You can think of this magnet as always on. It's always working. You can't really turn it off. That's why it's sometimes called a permanent magnet. It's made up of many smaller magnetic domains that are lined up in the same direction. But later I'll show you a type of magnet where this is not always the case. Let's take one of our permanent magnets and drill a hole in the center and put it on something that will allow it to spin. Now bring another magnet towards it. Our spinning magnet will immediately line up until opposite poles are right next to each other. Now switch out the side magnet. The same poles repel and opposite poles attract. If we keep switching out these side magnets, then our spinning magnet will just keep spinning. This concept of the spinning magnet is really important. We'll come back to it in a moment. Here's a metal bulb which is not a magnet. It's made up of magnetic domains, but they are pointing in random directions. Now let's take a wire, wrap it around several times, and then create a circuit. The current through the wires forces the magnetic domains to line up. That means we've just made a magnet, or more specifically, an electromagnet. It can do the same things that a permanent magnet can. It can pick up pieces of metal, and it has a north and a south pole which will attract or repel other magnets. But the electromagnet is special in the sense that it can be turned on or off, just like the light bulb. You can't do that with a permanent magnet. Now watch what happens when we flip the battery. The electric current was flowing this way, but now it flows the other way. This will cause the poles on our magnet to switch places. North will become south, and south will become north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way to do this is to just switch the wires. You should be aware that the electromagnet will get very hot if it's on for a while. Just a caution in case this video inspires any science projects. Let's come back to our spinning magnet. This time we'll replace the spinning magnet with our electromagnet. As soon as we connect the wires, the magnet turns on and it lines up with the side magnet. Now, in reality, connecting these wires would prevent the bolt from spinning freely, but what's important here is the concept of the spinning electromagnet. Now let's switch the wires to reverse the poles on the electromagnet. The same poles repel and opposite poles attract. Now reverse the polarity again. Same poles repel and opposite poles attract. If we keep switching the polarity, our electromagnet will just keep spinning. To make this stronger, let's bring in another permanent magnet on the side. Notice how this side has the south pole towards the center, and this side has the north pole towards the center. The side magnets work together to spin the one in the middle. This right here shows the very basics of an electric motor. But we need to make a few improvements. The two side magnets can be replaced with stronger curved magnets. And instead of a bolt with wires, we're going to use a metal loop. This is called the armature. Connect our wires and we have a circuit again. This time you can think of the electromagnet as flat like this with the south pole pointing up. Now the armature will spin until opposite poles are lined up. We can keep it spinning by switching the wires just like we did before. But this is a lot of work to sit here and manually switch these wires. We need to add something to the armature called a commutator. It's a ring with gaps on the opposite sides. The commutator will spin along with the armature. Now we connect the circuit with two brushes on the side. These brushes will slide along as the commutator spins, and they are spring-loaded so that they always maintain contact. The current flows from the wire, through the brush, the commutator ring, the armature loop, and back through the other side. Now we have our electromagnet and the armature spins. As we come around this time, the brushes will switch contact to the other side of the commutator ring. Remember, there's two brushes, so this is happening on both sides. Before the switch, the current in the armature is flowing this way. After the brushes switch sides, current will flow the other way. This means the electromagnet switches polarity, which will cause the armature to keep spinning. This commutator ring does the same thing as switching the wires like we were doing before, but this time it does it all on its own. It will continue to spin as long as we're connected to a battery. Disconnect the battery, no more electromagnet, and the spinning stops. Now so far we've only used one loop on the armature. This will cause our motor to have an irregular speed, and in fact, we could get stuck in this position, with the brushes halfway between commutator segments. What we can do is split the commutator ring and then add another loop. So first, the brushes are in contact with these two commutator segments, which turns on this electromagnet, which causes it to start spinning. Once we get to here, the brushes switch contact to the next pair of commutator segments, which means this loop turns off and the next loop turns on. Now this electromagnet wants to spin. The brushes switch contact and the next loop turns on. This keeps happening as our motor spins. It's almost like the loops will take turns being an electromagnet. Some electric motors will add many loops to the armature. This ensures that there will be a continuous spinning motion on the motor. This spinning force on the armature is called a torque. Stronger torque means a faster spin. There are some things we can do to improve the torque of the motor. Electromagnets are stronger when there are more wires. This is true when we wrap more wires around the metal bolt. And it's also true when each of our armature loops are made of many wires. The motor will have stronger electromagnets, which means it will spin faster. If you look at some pictures of real electric motors, you can see lots of wires wrapped around. And yes, this is the same reason. More wires wrapped around means stronger electromagnets. Another way to make this stronger is to use more electricity. Let's learn a few more terms here. The part that doesn't move is called the stator. In this case, it's the two permanent magnets on the side. These fit inside the edges of the motor case. The armature in the middle is also called a rotor. Remember, this is the part that spins. The axle goes through the middle here and then sticks out the back of the motor. What I've shown you in this video is called a DC motor. If you have a device that moves and is powered by a battery, there's a good chance there's a DC motor in it. Other types of electric motors will work a little differently than what I've shown here. No matter the type of motor, most of them will produce some type of spinning motion. Once it's spinning, we can use this to make different devices move. In this case, a kid's toy. Or even a fan that cools your room. The spinning of the motor can be converted to other types of movement, such as the side-to-side motion that we see in this fan. Or how about this electric cutting knife? Each blade is going back and forth. It all starts with the spinning of the motor to turn a gear, which then pushes these two pieces back and forth. So hopefully this video has made a few light bulbs go off in your brain.
Now I hope you have learned a lot from the video of Jade Owen on how electric motor works. Now this time, I'll be showing to you a video from Tech Insider. This was an innovation made by a group or team from Belgium. Okay, they actually created this Whirlpool turbines, which can provide 24/7 renewable energy for dozens of homes. I want you to check the concept behind this innovation, and it will show you how electric generator works. Okay, take note of the concepts and principles. I hope you have learned a lot from that video or innovation made by that Belgian company, because someday in the future you can be one of them, one of the innovators, well-known innovators. This time, I want you to get your pen and notebook, and then let's try to answer these questions. Okay, number one, write only the letters that corresponds to the correct answer. Number one, a blank converts blank into blank. You can pause this video so that you can think, can have a lot of time to think. What do you think is the answer? Number two, what condition is necessary for an electric charge to have a magnetic field around it? A, it must be in the copper wire. B, it must be isolated from the opposite charge. C, it must be moving. Or letter D, it must be motionless. Number 3. Electromagnetic induction occurs in a coil when there is a change in what? A. Electric field intensity in the coil. B. Magnetic field intensity in the coil. Letter C. Voltage in the coil. Or letter D. The coil's polarity. And number 4. When there is a change in the magnetic field in a closed loop of wire, A. A voltage is induced in the wire. B. Current is made to flow in the loop of wire. Letter C. Electromagnetic induction occurs. Or letter D. All of this. That's all for now. This has been Teacher Jethro Odoy, and see you in the next session. God bless you all and be safe always. Thank you.